Hello friends, my name is Kisan and welcome you in this video tutorial. In this video tutorial we are going to discuss about some of the enhancement in Executors framework which happened in Java 8. So here I am talking about the methods. There are two methods have been added in Executor framework in Java 8. So first method is new work stealing pool, which takes integer and an argument, which is nothing but the parallelism level, and almost similar method, I mean overloaded method, which does not take any parameter, right? So these are the two methods have been added in Java 8. So basically if you look into these two methods basically internally uses fork join pool, right? You can see fork join pool, and already we have seen in previous video tutorial how fork join pool internally works. But as we know that Executors provides you to create a thread pool in different ways, right? If you look into some other methods, like you have a new fixed thread pool, right? So this method uses internally a thread pool executor, right? And if you most of the methods basically that uses if you look into this method also use thread pool executor inside. So the main difference between Executor framework and fork join pool is that Executor framework provides a general purpose thread pool, while fork join pool provides a special implementation which uses work stealing pattern for efficient processing of fork join task. So here basically we are going to see how we can make use of this method, right, to create a thread pool. So here I have created a project. Here I have created a project with name new work stealing pool demo, and here I'm going to show you how to make use of this method. So let's make use of the executor. So this method is static, so directly you can call by its main its class name, right? So new work stealing pool. So this will give you the instance of, let's say this is called executor service, and now let's create a list of callable tasks. So I'm going to create a list, and let's say call level of, let's for simplicity call level of a string. Now I would say tasks and equal to new. I'm not going to create any implementer of list, but we can make use of the arrays, right? We have arrays class, and arrays as a method is called, sorry, spelling mistake, arrays dot as list, right? So it accepts var arc, right? So here, and if you look into the call level interface, so here we can define lambda expression like my task 1, something like this, and press Ctrl Shift O for organize import. And if you look into the callable interface, it's a marker interface, right, which is having one method is called call, and that returns some value but does not take any parameter and throws some exception, right? So as we know that this interface is function interface, so we can define with this behavior as a lambda expression. So that I have done over here, right? So this, I know you are familiar with how to write the lambda for functional interface, and here we can pass collection of object, right? So I would say task 2, now task 3, sorry, and task 4. Now we have a task, we have an executor, and executor has a method is called invoke all. So let's call invoke all, which accepts collection of call level. So this task we are passing over here, right, and we can call a stream method on it. We have a stream method, right? So basically this call returns you the list of objects, so we can call a stream method on it. So let's call a stream, and again we can call a map. map, and here we can define a future, and we can define lambda expression over here, and here you can say return, and now future dot get. Okay, now here we can have a for each, and here we can define system dot out double colon print ln. It's a method reference. So this feature also has been added in Java 8. Now we can have a try catch. Now let's add a throws. Now add return type, and if you run it, then we get my first task to till fourth task, right? So that's the use of here. For simplicity, just keep this demo shorter. I have used directly, I have defined call method as a lambda expression, but in real scenario you can have some complex logic, right? And you can pass the list of call level object over here, and all tasks you can execute by calling the invoke all method, right? And while in beginning itself, what I have shown you, there are two overloaded method of new work stealing pool. So one method does not take any parameter, another method takes parallelism as an argument. So how you can get the parallelism? Either you can pass some integer value, or if you want to get how many cores are used by your machine, that you can get by using, we have a runtime, right? The runtime class. So runtime dot get runtime, and you can say available processors, right? So this will give you the all available processors in your machine, and this available processor you can pass it over here, and you can pass it over so this would be the first line of code. This available processor you can pass it to this method, right? So there is one more method, overloaded method. So if I run it, then it will get the similar output, but this is going to use the number of cores number of cores available in my machine. So I hope you enjoyed this learning this video. This code I am going to upload on the GitHub, and GitHub location I am going to specify in the video description itself. So if you like this video, then please do subscribe my YouTube channel, and if you have any query, then please do post below to this video itself. I will try my best to answer those queries. So thanks for watching this video, and see you in next video tutorial.